Sometimes we're interested in the probability that an event does not occur. This is called the complement of the event, or the complement of event A. This is denoted as A with a bar on top. So that's the complement of event A, and it consists, ISTS, consists of all outcomes in which event A does not occur. In which event A does not occur. So if you think about it in a sample space, if you're thinking about all the outcomes where event A does occur, and then all the outcomes where event A does not occur, then this mathematical relationship between the two should make sense. That the probability of event A plus the probability that A does not occur equals 1. So the sum of the probabilities in a sample space equals 1 because at least something in there has to occur in your sample space each time you run the procedure. If you've listed all the outcomes and you haven't left any out, then something in there will occur, and it either is that A happened or that A did not happen. So the probability of an event plus the probability of its complement is equal to 1. And then we can just use math to show these other two relationships. We could subtract the probability of A from both sides, and we get the relationship that the probability of the complement can be found by taking 1 minus the probability of event A. And likewise, we could do the same thing and show that the probability of event A is equal to 1 minus the probability of the complement of A. So this relationship is very important in probability, and using these two is very common. We will be using these two frequently to find our probabilities. Okay, so let's look at an example. This is one we saw before. We had a bag with 6 red marbles, 2 blue marbles, and 4 green marbles, and we found the probability of randomly selecting a non-blue marble from the bag. We've already done this, but let's try this a different way. We still need to set up our sample space. Let's make sure we get that. So we have 6 red marbles. So we have red, 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 2 blue marbles, and 4 green marbles. Last time what we did was we found the probability of non-blue by taking the number of non-blue and dividing by the total number of simple events in our sample space. But this time, let's let non-blue be that event A, so that should be the same as 1 minus the probability of blue. So a marble in this bag is either blue or it's not blue. And so this is the relationship for an event and its complement. So now we could do the same calculation that we did before by saying 1 minus, now what's the probability of blue? Well, how many ways are there to draw a blue marble out of the bag? There are 2 ways. There are 2 blue marbles. And how many events are in our sample space? There were 6 plus 2 was 8, and 4, there were 12. So last time, what we found was 10/12, just like we found this way, by using the complement. Probability of A is equal to 1 minus the probability of not A. So we were interested in non-blue, so we said 1 minus the probability of blue. And those are the only two possibilities here in this sample space. We've accounted for every possibility, and you pull a marble out of the bag, you either get a blue or a non-blue. And our probabilities here should sum to 1. Okay, let's look at another example. We talked about the couple having 3 children. Well, this is a different example, but it would have the same sample space, because a couple having 3 children is the same sample space. And then we'll look at this probability of at least one boy. So our sample space here, let's do that again. We could have all 3 boys, or 2 boys and a girl, or boy, girl, boy, or girl, boy, boy. Or we could have a boy and 2 girls, or girl, boy, girl, or girl, girl, boy, and finally all 3 girls. So there was our sample space with every possible outcome. There are 1, 2, 3, 4, 5, 6, 7, 8 simple events in our sample space. Find the probability when a couple has 3 children they will have at least one boy. Let's use the complement. So the probability of at least one boy would equal 1 minus the probability. Now, so we want the complement of this. At least one boy would be no boys. Right? Because if you have at least one boy, that could be 1 or 2 or 3 in a family with 3 children. But the way this one boy does not occur would be that you don't have any boys. So that would equal 1 minus, well, what's the probability of no boys? Well, this one has boys, 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 boys. There's only one outcome here where there are no boys. So that would be one outcome out of 8 outcomes in our sample space. So this would be 7/8. So the probability of having at least one boy would be 7/8. We use the method of the complement to find that. Okay, so these formulas are very important to understand. So make sure that you understand this mathematical relationship and can use it in either of these formats.